All right, without further ado, we have our group, the Stars. Just to start off, I want to know how was your day today? Can you guys post that in chat?
Yeah, it's going to be helpful for us later on when we're testing our model. But I just want to say, oh, it's been such a long journey. Like our code is like over 800 lines. We've trained our AI on around 3,000 songs. We spent countless hours over time, like 3 to 4, maybe 6. And this is the grandest project any of us has ever tackled so far, I just want to say. So you might wonder, what is this project about? What does our project do? So we have one main goal in our mind as we were making this idea of what our project should be, and that is we want to attract attention for AI Camp. So we decided that marketing-wise, this idea needs to be unique. This needs to target a broad audience, and what topic would be better than music? So our code would essentially take in a sentence that you input, it would read your emotions based on it, and from there the code would generate lyrics and will output a text-to-speech file as well as a background track matched together to give you a song based on your emotion. And as you can see, this is a huge project, so we utilize distributed later to just make sure this project gets out on time. But for now, we will continue on with the presentation, and Greg will now present to you the sentiment analysis.
So the first part of our project is sentiment analysis. So we used a natural language toolkit to build this AI. And for our dataset, we chose Twitter samples as tweets are usually short and they match each line of the song that we were going to generate. So to start off, the website would ask the user for an open-ended question such as how's your day? And from this return either positive or negative. Then from this, we can derive the base emotion from the user, which sets the fundamental emotion of the whole sentence. Moving on to the next slide. For the second part, we use the text to emotion package built into Python, which outputs a set of sentiments and their values adding up to 1 based on an input. So for example, happy could be 0.5 and angry could also be 0.5, adding up to 1. And then from this, we generate a sentence which feeds it as a prompt to the lyric generator. So the sentence structure we'll have is quantifying adjective, noun, adverb, verb, preposition, quantifying adjective again, and then the last noun. So for example, a few happy penguins angrily walked alongside the dogs. So in this sentence, the base emotion would be happiness, and the specified emotion found from the second AI would be anger. And then the prompt that will be generated from this will be fed to the lyric generator once again, following the structures of sentence in and sentence out, which will soon generate the rap. And then some obstacles we faced with this sentiment analysis was sort of overlapping between the two AI and whether or not it would be beneficial to have both. We thought they would interfere, but in the end, we decided to use both. As we found out with some fine tuning, they can actually complement and build on top of each other. And another obstacle we faced was finding a suitable data set. We have considered using Amazon product reviews, but since the structure may be too formal, we decided to use Twitter samples in the end as it matches the informal aspect of the user input. And the final significant obstacles we have faced is inaccuracies, especially with the text to emotion package, but with the implementation of the NLTK AI alongside, it can still serve as a backup in a sense to maintain accuracy.
Interesting. So yeah, with that and with the input or with the output that Greg's sentiment analysis has given us, we need to generate lyrics. Now, in order to create lyrics, we first need a data set. First, we tried using the Calgo data set with 79 musical genres, which has like 380k lyrics. However, we decided that we want to exclusively narrow down on rap. And there's several reasons for this. One, we don't need to worry about voice synthesizers. We just need to worry about the flow and the rhythm, which we will get to that later. But with this Kaggle dataset, there was only 21 artists, and making a rap dataset without the big names, Eminem, NF, Drake, etc., it feels a bit iffy. So essentially what we did, and if you move on to the next slide, Devin, we used the Genius API. And what the Genius API can give us is if we tell it what artist to pull the lyrics from, it will give us a whole like a huge chunk of a bunch of their lyrics. However, these lyrics are definitely not clean. There was a lot of like different files that were, for example, like interviews. They included all of that as lyrics, which I think Leo will explain later with the pre-processing. However, with that, I was able to create a lyric data set based on the Genius API and some artists that we've found, and it's on slide 10, but some artists that we found that we believe can be a good representation of the rap genre. And although we weren't able to finish using all of the artists, we did get through half of our intended artist data set. So I will pass on the slide to Leo.
All right. So we took the data set that we created and we cleaned it a little bit. We had to do this by removing first any verses with extreme repetition, which was mostly just the chorus verses. And also files that, there were many files that were just interviews. They were not song lyrics. They leaked through, so we had to remove those as well. All right, next slide. And we used AI text gen to generate lyrics with our rap data set to fine tune our GPT-2 model. However, there are a few issues with our output. First, our model was not capable of creating rhymes, which is a big no-no for us. The syllables in each bar varied way too much, which would be an issue later when we put in the speech synthesizer and it tries to rap. And also the model loves to swear, and it has said many things I will not say out loud, but I'll just pass it on to Vincent and we'll come back to that later.
Yes. So with the issues that Leo has presented, we now talk about how we can rhyme. So we decided to use the DataMuse API, which can pass in a list of the rhymes when you pass in a word. Due to time constraints, we will only rhyme the last word. Someone might ask, well, if you're able to rhyme, like, that doesn't quite make sense because, Devin, if you move on to slide 15, you can see some examples. Now, we've decided to have these rhymes in two pairs of sentences. So two sentences will have the two sentences will be a pair, and that pair will have a rhyme. So for example, I'm a little baby, you're a little baby, and the second sentence would be later in the session we're surfing on a rainy. And as you see, it doesn't make sense. So you need something in between to make it make sense. And so this is where we get to another neural model that we included called the Roberta neural model. And if you go to slide 16, Devin, you can see that basic representation of what BERT is, which is a less effective model of Roberta, but it's it's a good graph for you to see how it kind of works. And essentially, with this neural model, we can link that rhyming word with the previous, with the original sentence, and removing some of the words at the end, therefore allowing us to have sentences that rhyme as well as make sense. I'm going to pass the slides back to Leo.
All right. So we take the rap lyrics generated from the AI text gen model, which is around 900 words or 50 bars. And we had to add everything that Vincent just mentioned. So the first step is checking the number of syllables in the sentences, and we only keep the ones in a certain range. Then we pair up the sentences and add masks as needed in order to prepare it for the rhyming process that he just mentioned. Next slide. Then the lyrics now go through the rhyming process, which Vincent talked about. So when creating the words to fill in, we make sure we accept only real words first, because sometimes it just gave gibberish and we don't want that. We make sure that it has a corresponding rhyme, because sometimes DataMuse just didn't return anything. When you entered something like 8, if one of these issues happened, we just found another word and put it in the Berta model. And at the end, we just cleaned any bad words and we censored them. All right, Vincent.
Yes, this is actually Emilio first, I believe, with the speech generation.
All right. So with speech generation, we actually ran through a couple of big problems that so for our problem analysis, what we would do is we would bash our head against the wall. And then if that didn't work, we would bash our head against the wall again. And then we found another wall to break. And then we found a new problem. But all we had to do was run around, and we finally found some speech generation. Our first speech generation actually did not work at all, though. It was very problematic. I constantly asked myself, what am I doing? Why am I here? Why do I exist? Because I had hours upon hours of sifting through documentation to find a simple speech Python to speech dialogue that would also accept syllables, rhyming schemes, and output that's unique to our bot. Our first speech generation was really bad and it sucked a lot. So let's move on to Vincent's solution.
Right. So I just want to point out, Emilio spent like so many hours just finding those few lines of code because it was just like not working. It was not outputting like the MP3 file. But moving on to our solution was Amazon Poly. So as you can see, it's a little bit more complex because that's because we were allowed to put in SSML formatted text. SSML formatted text allows us to customize the text, therefore allowing us to put breaks. And what do breaks do? Breaks allow us to make flows. Because in rap, flows and rhyming is very, very important. And so this way we can have flows inside our AI. However, due to a little bit of time constraints, we only had a very basic flow, and without and currently we have limitations in technology because the syllable counters are 100% accurate, and when they're not 100% accurate, it can be a little bit difficult to code the flows in. However, we, again, bashed our heads against the walls until we figured it out. So moving on to the front end, which you are currently looking on. So Devin, you can go ahead and take over.
All right, so the front end, prior to this project, I had no experience with front end development, and even JavaScript for that matter. But we gritted our teeth, all of us, but I gritted my teeth trying to find a template that suited our project. And I found Start Bootstrap, which our instructor recommended for me. And so I used that template and then I modified it to fit our needs and room for expansion. The template is web responsive, so even if you're on desktop, mobile, tablet, whatever, different aspect ratios, it will conform to that device, which is really handy for people that want to access our project page soon from now. It uses HTML, and JavaScript. And the thing about JavaScript is, for our model, we wanted it to talk. And to implement that in the front end, we needed a JavaScript audio player that had an HTML interface, which easier said than done. It was bad, but we eventually brute forced our way to find the solution, and it works most of the time. It should be good. I think we wrapped up all the bugs in I think the last 2 days, and it is modern. It is really modern looking. You're really going to like it once we go in depth after this slideshow, and it's going to be really good. Yeah, you can see from the picture. The front end's all nice and pretty, and then below the water is our Frankenstein of a code, so to speak. But all due respect, we had a lot of good brilliance and ideas for our project, and I'm grateful for that.
Okay, time for the beast that is the backend. There was a saying, I don't know if it's true or not, but it was true for us, where the front end was like 20% of the assignment, and then the back end was the entire like 80%, where we had to like dig through a hole to China. Basically, I didn't know I was getting myself into. I was the sole backend developer, other than getting immense help from our instructor. I had to like figure it out on my own. So the main problems were, one, connecting our code to the front end, which took up a big chunk of our work. Two, I had to learn HTML, Linux, and what a backend is. I also had to learn JavaScript on the way. And three, there was a lot of formatting problems because we would put our code on different compilers. I had like 3 compilers open while we made this. We would put our code on compilers, and then we would send it over to our backend, which made our code really incompatible because Flask and different compilers do not mix well. so I had to do a lot of cleaning up. I did a lot of compatibility, and the big problems I had were with a lot of get request errors. If you know about that, code kept showing default on the demo page. So we had to. It kept showing pre-existing files, so we had to work around it. And there was a day when our front end was gone, so I had to run over and switch jobs, do 2 jobs at the same time, started juggling. But other than that, I had a lot of fun doing this, and I appreciate backend developers even more. But we can move on. And yeah, here are a bunch of pictures of my problems. GitHub, Stack Overflow, big MVP. You know, me and my boy Stack Overflow, we go way back. And as Steve Jobs says, you gotta respect the people who are loyal. Stack Overflow is so loyal because they're not preying on your downfall. They're helping you each step of the way, and that's what helps the most. We can move on though.
And yeah, next slide would be please show the next slide, Devin, just to embarrass our instructor, and also just to say a huge thanks to our instructor. You're not, the last slide not showing, by the way, Devin. Anyways, Emilio's getting the model ready, so once Devin, are you there?
Oh, no.
I think Devin's frozen. Oh no, Devin might have crashed.
Yeah, I'm here. It should be just.
Oh, now it's displayed. Sorry, you just lagged. But huge shout out to our supreme leader, Siqi, who helped us so much along the way. We've dedicated this project to the supreme leader. As you can notice, the homepage is just Star Wars themed. But anyways, Emilio, take over for the presentation for the model.
Okay, so now we have our demo. The reason I asked how your guys' day was because we needed it for the demo for our rap, because our rap actually takes your prompt and then puts it into our rap database, makes some little rap lyrics that are based on the emotions of your prompt, and then we display it on the screen. Devin, you can stop screen sharing. So now I'm going to show you the model that we used. And to preface this, we take lyrics and we generate it from a rap data set. So of course, with rap and music in general, there are going to be a lot of swearing, there are going to be a lot of bad words, and to show that we included some lyrics that are quite harsh if it's for some people. I hope it's fine for you guys, but I do have to say that this is solely because we took it from a rap database. So whoever said I had a blast today, I like that saying, so I picked it. And we decided to ask the prompt earlier on because it takes 2 minutes, 3 minutes, and we don't have enough time today. Let's be honest, everyone wants to leave. So let's get on with the show. This is the display. It said blah blah blah. Let's play it. Oh wait.
Are you sharing sound?
Audio. Sorry, I'm really excited. Okay.
Hippopotamus for Christmas. You see, I'm just a man of my opinion isms. Just learn to be humble and stand up to people. They want to end with a heart of TH and treacle.
It's generated a lot of really funny prompts along the way. But yeah, it's really cool. I'm really excited. I'm really glad that I got to work with everyone, and I'm sure everyone's was really excited to work on this. We probably drained all of Siqi's life force, but it's fine. We'll sleep for 5 days after this. So thank you so much for listening. We hope you enjoyed this presentation.